In this demo, I will show the use of the SEGEER SystemView. I have recorded the data for 3 tasks with FreeRTOS. I'm using FreeRTOS, and the Nucleboard I'm using STM32F303RE. So this is recorded with the SEGGER buffer. It's not a stream, it's recorded, and the data then loaded in the SEGGER SystemView for analysis. So if we see the task here, this is for the task, the CPU load here, it's almost 33% for each one, which are taking all the CPU load, because in this task I used the blocking delay. We can see here also how the tasks are switching here. So it's the blue task and the red and the green. So blue, green and red, all switching between the scheduler, switching between them each 1 millisecond, and they take in all the CPU load, 0% for the idle task. This is one using blocking delay. In the next demo, just now, I will show stream data for the SEGGER view using JLink with more than 3 tasks, and we're gonna to see how the CPU load will be. So let's begin. So this is the task I'm using. I'm using here STM32. So I'm using three tasks for green, red, blue, and for manager, I call it manager DCM handler, and accelerator motor, and for the revolution for the RPM, the motor encoder. And here also I put another task to handle the receiving via UART and the sending via UART, and some queues. So let's build it and run it. Okay, let's show just the debug configuration that I'm using SEGGER JLink. Accept, switch, and resume. I put this apart, and I'm going to see first the LEDs are tested. Don't know if you can see it here, are on. Now when I continue, the motor will be tested first, and then it will stop. LEDs are off. This is not yet the FreeRTOS, it's just the testing. After that, the FreeRTOS has started and all the functions are ready. Now I will start the FreeRTOS from here. Okay, so I have record the configuration for JLink, and then can start from here. Okay, so the functions are started. We have the 3 LEDs here, and we have the other task manager for DC motor, the accelerator, the motor encoder, RX and TX. Here I'm not running the motor yet, but when I run it, let's run it with the dial on GUI Linux. I made it on GUI Linux. You see here it's increasing. I'm activating the other task. I'm decreasing, and always activating. When I touch the dial, the tasks are activated, and you can see in here the motor is in acceleration. I will decrease, decrease, decrease. I put it 0, almost 0. Let's adjust it with the dial to put 0. Now it's 0. Okay, let's analyze. So we have other tasks still going. The motor encoder, this is activated, but there is nothing of RPM. It's just sending the same revolution, so the speed will be 0, but it's still sending. Here the tasks are running, the green and the blue running. If you see the idle task here, it's 85%. It means the CPU is less used, is only used 14%. The other 40% are distributed on the TX, the AX, the motor encoder, accelerator, the manager, and the 3 tasks of the LEDs. You can see here it's running. Let's stop it. Okay, it's 88% here. See here.